Hello student. So in this video, we will learn about the derivation of the first order reaction. Okay. So let us start for the derivation. So now we will write a general equation A to P, where A is the reactant and P is the product. Okay. Though then I will write the rate for this reaction. So the rate is equal to the dA by dt, where in square bracket A is the concentration of the reactant and here the concentration of the reactant is decreasing with respect to time. So therefore, I put here minus, and this is the dP by dt, and in square bracket P is the concentration of the product P. Here the concentration of the P is increasing, therefore it will be positive. Okay, and the rate for in term of rate constant, so it will become k time concentration of it to the power 1. So yeah, so I'll so power 1 is the first order reaction, therefore the concentration raised to the power will be 1. Okay, so I'll derive the relation between time, concentration and rate constant. Okay, so I'll take this one and this one here. Okay, so yeah, so here I'll take this one, so I'll arrange this. So what I'm doing here, I'm keeping the concentration of a denoting the concentration of a with C. So now keeping the C here, so this will become dC by dt is equal to kc, and yeah, so here I will do like arranging C in one side and k dt at one side. Okay, so this will become minus dc by C is equal to k dt. What I have done here, I am shifting the C to the left and dt to the right. Okay, now integrating this equation, so this will become integration dc by C is equal to minus k dt. Okay, so now here k is the rate constant here, constant, therefore it will come out from the integration, and now I'll write dc by dt is equal to minus k and dt. Then I'll put the limit. So suppose at time t is equal to 0, then the concentration concentration will be C naught. Okay, C naught, what is the C naught? C is the initial concentration. Initial, okay, at the starting, the concentration of the reactant, and after time t, the concentration of reactant will become Ct. Okay, then integrating this equation, so dc by C, the integration of this will become ln C. So here I am using different integration. So yeah, so the integration of this dx by x is equal to ln x, and here a and b is the limit. It is called lower limit, or this is called upper limit. So this will become this one, and putting the upper limit minus lower limit, and we will use the formula ln b minus ln a. We can write it ln b by a. Okay, so that I have done here. Similarly, so this will become ln ct minus ln c is equal to minus k. Putting the limit here, upper limit minus lower limit. So t minus 0. So this will become ln c by ct by c naught is equal to minus kt. Okay. Now I am simplifying this one. So what I am doing here, I am this written ct by c naught. So I can write c naught by ct and raised to power minus 1. Suppose here written x by y, so I can write y by x raised to power minus 1. So simple mathematics. So now here power is minus 1, so I can keep this one before the ln and log. This is the simple formula. Suppose ln x is there raised to power minus a, so I can write this type. Okay, so multiplying both side minus with minus, so this will become ln c naught by ct is equal to kt. Then arranging little bit, so this will become ln 1 upon k is equal, t is equal to 1 upon k ln c naught by ct. Okay, this is the formula for in term of ln. Now we can put into in term of log. So we will use the relation between ln and log. So we can multiply ln is equal to 2.303 log x. Similarly, we can keep here t is equal to 2.303 by k log c naught by, and then I'll derive the formula for the half life of the first order reaction. So half life, what is the half life? Half life is the time in which the concentration of reactant reduced to one half. Okay, so Ct will become C naught by 2 and T is equal to T will become T1 by 2, that is T half. Okay, so keeping this value, putting this value into the T is equal to 1 upon K ln C naught by Ct. This will become T half is equal to 1 upon K ln C naught by 2. C naught will become cancel and this 2 will become ln 2. Okay, so now it will become T half is equal to ln2 by K. The value of ln2 is 0.693. Okay, and divided by K. This is the formula for the half life. So this is the relation between. So I can say we can see from this formula T half is independent from the concentration of the reactant. Okay, so this is the only relation between rate constant and T half. The half life is of the first order reaction is independent from the concentration of the reactant. Okay, and the time is dependent on the concentration of reactant initial concentration as well as time t concentration, and this is the rate constant. Okay, so we have derived the half life as well as formula for the time. Okay, so here is going to be in. So thank you.